Oh crap, where'd it go?
Today's the 16th, right?
Yeah.
Yeah.
You think it's Monday, it's actually Tuesday.
I'm still not used to the 1 to go to 10.
Yeah, me either. I'm not used to the 1 here. The last time I had to write a date, it was like the 5th. Okay, today we are talking about properties of exponents. We don't have as much class time, so I intentionally picked something a little bit short that, again, I hope is mostly review for you.
No, I don't have a pen.
Today's date is the 16th.
Yay!
It's property of exponents. Things you need to know about exponents or need to remember about them. Start with the simple rules. If you have a number, any number, use the letter A, and you multiply it by that same number, and each of these numbers is raised to a power.
Why did you put M and N?
I picked 2 letters at random to represent unknown numbers.
Wouldn't it be
A lot
this?
of books.
Oh, okay.
Now, they're 2 different numbers.
Oh.
Okay? So you're multiplying.
Oh, wait.
I hope so. It gets hard, a little bit harder.
Do this equals A M plus N.
Very good. I figured this was a rule some of you had seen before, so I was hoping I could move a little bit quickly. You add the 2 numbers. Examples of this can be with numbers or variables. If you have 3 to the 9th power times 3 to the 4th power, how can you rewrite that?
3 to 13.
No, it's 3.
3 to the 13th. Yes, the base doesn't change. That'd be a good thing to review. If you have a number raised to a power, what's this part called?
The
I
base.
just said it. The base. What's this part called?
Yeah.
Exponent.
It's actually called the power. The whole thing is called the exponent. But yeah, you can call it, if you call it the power of the exponent, I'll know what you mean. But yeah, that's the base. That's the power the base is raised to. Remember, the base doesn't change. Jordan started to make an understandable mistake and caught herself. 3 to the 9th times 3 to the 4th is 3 to the 13th. It doesn't become 9 to the 13th. Another example with this is if you have x squared times x cubed. What do you have then?
X to the 5. Oh, 5.
X to the 5th. You're jumping ahead to the next rule.
Yeah.
So these are 2 examples of the simplest property of exponents. Fairly easy one to mess up. Here's one. What if you have 5 times 3 to the 9th, and that's multiplied by 4 times 3 to the 6th?
Would it be 15 to the 9th times 12 to 6, and then you add...
No, it wouldn't. It wouldn't. I can see why you think it would, but this actually goes back. We're going to do some math, and you guys are going to trip over concepts you haven't thought about since 5th grade. Actually, but the 5th grade stuff, 6th, 7th grade stuff is what becomes the most important. Trips kids up through calculus. Order of operations, which comes first, exponents or multiplication?
Exponents.
Exponents. So, Nimi, I cannot multiply 5 times 3 because I haven't figured out what 3 to the 9th is.
I know.
But I'm not going to ask you what 3 to the 9th is, though.
I know, but would you do, like, 3 times 3 to the 6, but instead of keep it, so it'd be 3 to 15?
Yes. So yes, that's what you would do with the exponents in there.
And then 5 times 4 is 20, so it'd be 20 times 3, times 3.
She's correct. Nimi's got it figured out, and I'm going to show an intermediate step. Do you guys remember from like 3rd grade learning how that you could multiply in any order? Okay, so we're taking like a 3rd grade concept and a 6th grade concept, and we're going to say exponents have to go before multiplication, and you can multiply in any order. So I'm going to change this to 5 times 4 times 3 to the 9th times 3 to the 6th. And as Nimi pointed out, then I can do the multiplication. 5 times 4 is 20. And then this part follows the rule we just reviewed, and that becomes 3 to the 15th. And you have to leave it like that, especially if this is on a non-calculator part.
Oh, you can't do 60?
No, excellent. You guys are going to trip over that for the next couple weeks. Exponents must come before multiplication in order of operations, which means I can't multiply 20 times 3 because I have to raise it to the 15th power first.
But you can still solve it.
Nobody wants to solve it. Your calculator doesn't want to solve it. Yeah, it can be done. But that number's huge. We'll go into...
I'm sorry. What's the point of getting the whole thing if you're not even going to solve it?
Exactly.
No, seriously.
These are the basic skills you'll need for exponential functions, for logarithms, and for scientific notation. So, actually, it's kind of funny you said that because scientific notation, do you remember learning that?
Yeah.
Okay, scientific notation is actually all about, because these numbers are too big to solve, you write them like this instead.
Set all the zeros up there.
Yeah. So it's kind of funny. Scientists actually find it easier to leave things in forms with exponents rather than write out all the big numbers. These numbers get huge quickly. We'll talk about that a little bit later. Okay, so that's what happens when you're multiplying. We just talked about multiplication. What do you think I'm going to talk about next? Division. If you have any number raised to some exponent divided by another number, what do I do with these exponents? I subtract them. So the base stays the same, and I subtract these two numbers.
I feel like you learned that in Algebra 1.
I hope to the heavens above that you did. Actually, I really hope this is a review. In a moment, I'll get to the stuff which you may or may not remember as well from Algebra 1. Quick example of this, if I have 5 to the 7th power divided by 5 squared, that is 5 to the 7 minus 2.
When you do fifth.
5 to the 5th is what you would do.
That's cool because you know the saying cross the line, change the sign?
Yeah.
That works out. That's simple.
Hold that thought. We're going to get to that in a sec. Okay, now here's so the next thing. This should still, I hope, be an Algebra 1 review. What if I have a raised to some power divided by a raised to the same power?
What?
What does it equal? Well, both those answers could be correct depending on which part you're answering. Which part equals 0, Sarah?
The M.
The exponent, yes. So this is a to the m minus m, and whatever number that is, it's the same number, so that's a to the 0. But as Matt pointed out, what is anything divided by itself?
1.
1. Anything divided by itself is 1. Here's the world's shortest mini proof of why anything raised to the 0 power equals 1. Because the way you would get a 0 exponent is if you had something raised to a power divided by the same thing raised to the same power. Okay? Just out of curiosity, do any of these rules work if these numbers are different?
No.
No. If this is not the same number, the same base top and bottom, this rule doesn't work.
So, like, couldn't it be technically 1 to the 5th instead of 5 to the 5th?
No. Good call. Okay, you're doing the same thing that... Order of operations. Which comes first, exponents or division? Exponents. So I'm not allowed to divide the 5 by the 5 until I deal with the 7 and the 2.
Yeah, but after you dealt with the 7 and the 2, then...
Well, after you deal with the 7 and the 2, you no longer have a fraction.
I know, but...
No, you can't. It doesn't work that way. The only two ways to deal with this are this shortcut, and this is really a shortcut. I mean, the long way to do it is to figure out what 5 to the 7th is. What's 5 times 5 times 5 times 5 times 5 times 5 times 5? Yeah, I don't know either, and I don't care. So 5 squared I know is 25, and then divide it. But you will get this number every time, so you want to use this rule. But no, you cannot divide the 5 and the 5. Thank you for asking that, actually, because I know it looks like you should be able to, and I know somebody's going to make an error like that at some point. Hopefully not me.
Well, from the looks of what you said there, you said that if the base and the top number are the same... Oh, but never mind.
Yeah, if the base and the top number are the same, that allows you to do the subtraction.
Yeah, but it, like, never mind. I was getting confused with the exponent. Like, you're saying also the exponents are the same, then it could be 1. If the base...
Yes, thank you. Yes, if the base and the exponents are the same, then it has to be 1.
Okay.
So it's like, let me do another example of that up here. If I have 5 to the 57th power, I wouldn't want to work that out, would I? No, I think your calculator might even give what's called an overflow error if you try. And that's divided by 5 to the 57th power. No matter how huge that number is, this is going to equal 1. And if you follow this rule, it'll equal 5 to the 0 power, which is the same thing as 1.